There are different ways to manage dependent demand. When the demand for your product depends on demand for other products, or where the inventory that you're using, your demand for it, of course, depends on the demand you're getting for your product. So when we have this relationship between sub-assemblies and the main assembly, or the raw materials that are derived from the finished product and the finished product itself, we have to consider the time and process between the different items. So when we look at dependent demand and how we manage that inventory, you can have a pull system or a push system. In this video, we're going to look at the pull system, and in later videos, we'll look at the push system. So when we talk about a pull system, what we're talking about is a work center pulls items. So we're going to get the items from the preceding workstation as needed. So the big difference between push and pull is that when you finish making part A, you push it on to part B that uses A to make B. In a pull system, what you have is that part B station that uses A in it will say, hey, I need part A now, and will pull it forward when they need it. So who is managing the inventory? Is it that the first step is pushing it to the next step, or is it that ending step B is pulling it up when they need it? So push or pull. When we talk about a push system, what you're using is what's called material requirement planning. So we're determining the purchases and production of these dependent demand, these sub-assemblies, these raw material components. We're determining or forecasting how much we're going to need. We start with the raw materials and the sub-assemblies, and then we move it forward. We push it forward as it's done. With the just-in-time delivery system, we're using a pull system. And so what's happening here is that we're moving the parts or the work in process as needed. So our definition here is a system of production in which processing and movement of parts or work in process occurs just when needed. So we're going to look at in this video is how that works and the benefits of it. So with the just-in-time, the idea here is that if we pull just what we need to our workstation, then we don't need a whole lot of safety stock. We don't need a bunch of excess inventory. We're pulling up just what we need in the amount and the time that it's needed. So the goal of just-in-time, often combined with lean manufacturing, is that there's a balanced, rapid flow in terms of production. So what we need then is to utilize a number of the ideas that we've learned in previous topics or levels this semester. So when we talk about balanced rapid flow, what we need to do is have assembly line balancing. We need to make sure that we know how much needs to be produced at each station and that we don't have any particular station holding up the process. So that's when we get into that discussion about cycle time or talk time and how much time is being allocated at each station to produce the product. Can we balance the flow through? This also utilizes the idea of the theory of constraints that we discussed earlier this semester. And if you remember the theory of constraints, we need to be mindful of the bottleneck. Make sure the bottleneck always has something to do. We're putting small lot sizes, small sizes of material through so that there's not this huge amount of inventory that starts to build up in front of the bottleneck. We want that nice, steady, balanced flow. So if you think back to the theory of constraints and that discussion about the drum, the buffer, and the rope, it's about that keeping time, letting the bottleneck set the pace, and making sure that you've managed the flow in both directions on both sides of that bottleneck so that you have that nice steady process through. Now, when we talked about the theory of constraints, one way to deal with that bottleneck was to have a stockpile of inventory the bottleneck could constantly be working on. And that way you never had your bottleneck idle. Well, if we're doing just-in-time lean manufacturing, we don't want a huge stockpile. We don't want a bunch of safety stock. We don't want to pay for a bunch of inventory storage. So it becomes even more important to balance that flow through, because you don't want to add in that extra buffer of additional inventory to help manage the flow. You want that flow so perfectly smooth that the bottleneck is always getting materials right when it needs it. If we can do this, then we can eliminate waste. And when we talk about waste, we're talking about, we don't want to have work in process that is depreciating or going bad because it's waiting for its next stage in the process. So we don't want that depreciation or obsolescence that comes with having too much excess inventory, too much safety stock on hand. So we want to get rid of that. We also want to recognize that just-in-time lean manufacturing requires quality management. And so we need to do things right the first time. It is wasteful to have to make a product, have it be defective, and then have to remake it or amend it or fix it, because all of that becomes wasteful. So if we can well manage our quality, then we won't be throwing away as much raw materials, work in process, and defective products. We also want to reduce disruptions. So the idea with the just-in-time lean manufacturing is we don't want to have to be waiting for materials, right? Back orders and problems with supply chain management can create issues. And so what happens then is that your production is idle, waiting for that material that was supposed to come in. So when we do just-in-time lean manufacturing, we're going to need good supply chain management. We're going to have that close relationship with our other companies so that we know how much they have on hand. We can track the inventory movement. We know how much lead time there's going to be. And that way we can place orders in sufficient time to have it arrive just in time, just when we're going to need that. Otherwise, we get disruptions in our production process if we then have to wait for materials. We also don't want those disruptions that come from issues with quality, where we then have to stop our production process, refit, retool our equipment to different specs because of quality issues. So you can see that just-in-time lean manufacturing starts to pull in all these different components we've been talking about all semester, from quality management, supply chain management, our facility layouts, our productivity and capacity planning. We're pulling all these pieces in together. So we need to reduce disruptions with that. So that means not having to redo product. That means not having to wait for our materials. We also need flexibility. So the goal of just-in-time lean manufacturing is to reduce change over time. We want to have the ability to offer similar products, but not have to stop our productions for long periods of time in order to do so. So, for example, if you're Celestial Seasonings and you make tea, you have different production lines. You have ones that make mint tea and ones that make herbal tea. Well, the challenge, of course, is that if you want to switch a production line over from mint to herbal tea, you have to do a thorough cleaning of all the production line. Otherwise, all your herbal tea will smell like mint. And so you have to be aware of the impact of both storage and production of one product, right, permeating the other. If we're forward and we're looking at the change over time between products, maybe we're making an XLT F-150 versus a Lariat F-150, do we need to fully revitalize the entire production line or just pieces of it? Are there ways to reduce the change over time? Are there things that can be done while production is in process to prepare to switch to a different product mix? That means that we don't have those disruptions in production. So do we have that level of flexibility? We said quality management was a key part of that just-in-time lean manufacturing, that ability to to prevent the defects before they happen. Because if we are creating defective products, that creates waste in just-in-time. The key here, this lean part, the lean has to do with the waste. The just-in-time has to do with that responsiveness and reducing the disruptions and creating the flexibility. But the lean part is about eliminating the waste and eliminating the excess inventory that has to be stored. So if we're going to be lean, we need to have a good quality management. And we know that good quality management depends on TQM. What were the 3 parts to TQM? We have continuous improvement. And so we've talked about the PDSA or Deming cycle to get you that continuous improvement. Plan, do, study, act. Okay. We also have involving everyone or employee empowerment. So we need everyone in the company to be involved in improving quality, regardless of your position. If you're CEO, if you're the night manager, if you are the janitorial staff. You need to be empowered to recognize issues and make recommendations. And then TQM is all about customer satisfaction. Our definition of quality comes from what does the customer want. So we have to understand what the customer wants from us, what is their definition of quality, and so we can continually work to improve to meet those customer expectations. Well, how do you do that with just-in-time manufacturing? Well, the key here is a term called Kaizen. And when we talk about Kaizen, what we are talking about is gradual improvements. Okay, so nothing huge or big. These are small incremental changes that again involves everyone. And we're not talking about huge amounts of money. So we're not paying millions of dollars, hiring consultants to come in and tell us how we can do things differently. Kaizen is about empowering your employees to observe, recommend, and make change. Okay, so no great sums of money on technology, on consultants. It's all in-house. It's all small incremental change. And what we're doing is we're looking for things that we can test out to see if they improve our process or the quality of the product. And then if they do, then we can apply them everywhere. So if you've ever been involved in Lean Six Sigma operations at your company, we talked before about Six Sigma, which Six Sigma is by definition for companies that do large continuous manufacturing, because Six Sigma is 6 standard deviations in terms of getting the defects to be such a small percentage in your mass production. But what we often hear nowadays is this idea of Lean Six Sigma and being a yellow belt or a black belt in Lean Six Sigma. What they're really talking about here is Kaizen. It's about empowering the employees to find little changes that can improve the operations of the company, and that can then be applied across the institution. So we're looking for something like a way to reduce paperwork that might be beneficial for one department or office, and then we can apply it to the others. We learn by doing. We do Kaizen. As I said, what we're doing is we're testing it out, and we are using that PDSA cycle by using direct observation. So we test it out, we see if it works, we see what happens, and we collect data. We analyze it, we see if it is effective, do we tweak it, and can we apply it elsewhere? So Kaizen is that approach that is really part of that PDSA or continuous improvement cycle. What differentiates a PDSA just in general, that Deming cycle, from Kaizen is that Kaizen is this small incremental changes from within your institution to improve. Okay. All right. So the goals of just-in-time lean manufacturing is to have a more balanced flow, to eliminate waste, reduce our disruptions, increase our flexibility, and have that continuous improvement. So when we talk about eliminating waste, let's dive just into that one in a little bit more detail. There are 8 different wastes that just-in-time lean manufacturing focuses on. So we want to make a list of these 8 wastes that just-in-time lean manufacturing hopes to eliminate or substantially reduce. The first one is overproduction. Overproduction is when you make too much. So if we don't do proper forecasting of demand, then we're going to produce too much. If we need a lot of safety stock, a lot of excess inventory, just in case, then we're overproducing. So if we can produce just what our customers need, and we can get just enough of the raw materials that we need for production, then there's no overproduction in our supply chain. But when we talk about just-in-time lean manufacturing within a particular company, we're focusing that overproduction on not making too much of our product and then having to store it. Okay. All right, the second waste we're trying to get rid of is the unnecessary inventory. And here we're talking about reducing that level of safety stock, not storing a lot of work in process, by having that pull system where we can contact suppliers or other parts of our production process and just get that material, just the amount we need when we need it. Then we don't have to pay for a bunch of storage. Then we don't have a bunch of work in process that's becoming obsolete or depreciating. The next waste we're trying to eliminate is that of waiting. If we have to wait a long time for our materials that we need to arrive, that is time we are paying workers to not make product, and this is a waste of money and the time of our workers. So we want to reduce wait times. We want to do a better job of monitoring our inventory levels, knowing how long it's going to take for the materials to arrive, where to get them from. And that way we can place the order so it arrives just in time when we need it. One of the ways we're going to do this, we'll look at this in our next video, is to use what are called Kanban cards or Kanban cards. And what they do is they show you how much to order, when to order, who to order from. And it's set in the process as you use up the inventory as a flag so that you order, and then there's a lead time for it to arrive, and then that's all considered, and so it arrives just in time when you need it. The next one we're trying to eliminate is over processing. So the idea here is that if you build a product and it's defective, you have to go back and fix it. This is over processing. This is extra steps that we have to do. And they can occur for 2 reasons. One, that your product is defective and you now have to go and fix it. Or you have additional steps in your production process that you don't need. Okay, so as we look at the process flow diagram and we look at the transformation or where we add value, we look at the steps of the process and say, okay, well, does all of this add value? Now, that doesn't mean you get rid of the double checks in terms of your critical control points or your quality management to assess your quality components, but do all of the steps in the process add value? And are you having to go back and redo and fix things because there's a problem with your quality management? Inefficient work methods is another waste we're trying to get rid of. So again, do we have steps that are not adding value? Inefficient work methods include things like too much transportation. So if we are having to constantly move the work in process, then perhaps the layout that we're using is causing inefficient work. We're taking up too much time and money with logistics. And perhaps if we laid out the facility differently or located our business somewhere else, then we would be able to do the work with less cost, less time, less effort. So we need to look at our people and what they're doing and our process to see if it's adding value. And this ties also to underutilization of employee knowledge and skill. So are you using employees? Do they have the right level of knowledge? Do they have the right level of expertise for what they're doing? And so are we actually utilizing that skill and knowledge? So if you think about it as a company, we pay for degrees, we pay for additional training of our workforce. And so are we properly utilizing that? Are we empowering our workers to use that skills and training that they have? Are we taking advantage of that skills and knowledge? And that will then contribute to that efficient work methods, because you're going to get your most bang for your buck from your employees if you are using them based on the skills and knowledge they have. All right, 1, 2, 3, 4. What else are we missing? Oh, I mentioned before about that inefficient work methods, and that would be anything not adding value. There we can add specifically the one of unnecessary transportation. But inefficient work methods can also refer to the processes on the production line. What do you have your workers doing? Are they spending too much time filling out paperwork that nobody reads, writing reports that no one looks at? So are we getting the most value for the work? And the last one we have here is producing defective products. So producing defective products, of course, is inefficient for our workers. It is over processing if we have to go back and fix it. But in addition to that, we have the lost money from the defective products that are having to be thrown away. We are having the additional contribution to the landfill of the defective products itself. So there's lots of overlap in these wastes. And so we can, because of the overlap we have in these different types of wastes, we can tackle them as a group. And so we want to design a just-in-time or lean manufacturing process that reduces these wastes. We don't want to make too much. We don't want to have to make it more than once. We don't want to waste our time and take longer than necessary when we make it. We don't want to have to sit around and wait, slowing down that process. We don't want to have too much excess inventory losing value. We don't want to have too many products that are defective that are also worth nothing. So you can see how it all kind of fits together, these wastes. So how do we go about resolving this issue? Well, there are a couple different parts to designing a just-in-time process, and these are going to use, as we spoke before, those pieces that you've been learning throughout the semester. So when we design a just-in-time process, we want to distribute the workload evenly across workstations. This is where your knowledge of that assembly line balancing comes in and looking at that cycle time or talk time. We also said before that this is where that idea of the bottleneck and the theory of constraints, that flow, comes in. We want to have production flexibility. So we want to be able to reduce that change over time. And there's some different ways that you can do this. So let's just make a little bit of a list here of how we can reduce that change over time. So we can create more flexibility by cross-training our workers. So if they are able to do multiple parts of the process, then we can relocate them during the process. If we no longer need as many people doing one thing, we can then relocate them to work on a different component or different process. We can stick to using more small machines. Whoops. So if we can break our production process down into smaller units, smaller machines in the process, then when you do things like your changeover, some of your machines and parts of your process don't have to change while others do. And so that's what you see, for example, with Ford when they're switching from an XLT and a Lariat and a King Ranch, is that a lot of the assembly line is the same, and only some of the machines have to be adjusted or adapted for different size doors and side mirrors and the different components. So if we can use more and smaller machines, then that will give us a bit more flexibility and reduce that change over time. We can add production flexibility by using some safety stock. Remember, we want to keep that from being too much. And we'll talk more about why we don't want all this excess inventory in a moment. But some safety stock will allow for production flexibility. So if you think of your production line, if there is a bit of excess work in process or inventory, then part of your process can continue to work while we change over other parts of the process. So that allows us more flexibility. So we're continuing to produce, but at the same time, we can change up our product mix or how we're operating. You can also allow for some flexibility by keep some of your capacity idle. Actually, let's reword this. Keep some idle capacity. So another part of flexibility is that being able to adjust or react to changes in demand from our customers. And so if we don't operate at a full 100% capacity, then that gives us a bit of flexibility to change and adapt. So if at some point we need to produce more, we can without taking extra time by having that ability to adjust and add a bit more without exceeding that utilization. So we want to keep a little bit of idle capacity just to give us that future flexibility. All right, the third piece here of designing a just-in-time process is to have small lot sizes. So this is the amount of work in process or raw materials that are moving through your production process. If we reduce that quantity kind of into smaller chunks, then as we talked about with the theory of constraints and the bottleneck, that helps with that more seamless flow because you don't have, if you think about your machines and your process, maybe you have certain people or machines that can handle 100 units an hour and others that can handle only 50 units an hour. Well, if we are putting through 100 units an hour, when we get to that person who or machine can only handle 50, then now we suddenly have this excess inventory stocking up and we have this bottleneck in the process. Now, a lot of this discussion has really been about manufacturing. So we envision, a Ford plant for trucks, or we envision a company that has an assembly line, that's assembling cabinets or making toys or computers, adding each component as it goes down the line. But when we look at this just-in-time process, also can apply when we provide services. So those of you who are going to become accountants, work for marketing firms, HR, think about the work that your people are doing. Are they cross-trained? So you can then repurpose them and have them do something else. When you think about the amount of customers or clientele that your bank sees per hour, you have some of your workforce who can manage seeing 10 people an hour and some who can manage 5. Well, if it's a process where we need to hand off from a teller to a consultant or advisor, then perhaps we need to be looking at smaller sizes in our bookings so that we can have that nice steady flow, so that you don't have tons of people who've seen the teller now sitting in your waiting room waiting to see the advisor, because the advisor is the bottleneck. They can only see so many people, but the teller can see a lot more. So do you slow down the pace a bit and have smaller lot sizes or groups to help manage that flow through? So a lot of these apply regardless of what your company does. Now, the fourth piece in designing a just-in-time process is to reduce your setup time. So if we are doing changeovers in our production process, then we will need to take down parts of the process and change them over. We will need to add in machines as we change our product mix, what we're making, what we're offering, the services we're providing. We may need to rearrange how we've laid out our facility in order to offer slightly different services. So this is all setup time. When you go from offering one good or one service and you switch over to slightly different, what has to change? The layout, the machines, the people you have in place. This is setup time. So as we look to reduce the setup time, this will give you more flexibility in your production. One way to do that is have those cross-trained workers. But the other piece is to have more multi-purpose machines. If you have more general equipment that can do lots of different things, or if you have computer numerically controlled machines, CNC, in your automated process, then you can recode them to do something different. So this will reduce your setup time, because then it just comes down to writing a line of code as opposed to replacing the entire machine with one that does something different. So to have more lean manufacturing, more responsive, more just-in-time manufacturing, then we're going to be using more multi-purpose machines rather than very specific machines that do a very specific thing. All right, the fifth piece of designing a just-in-time process is a cellular layout. And with a cellular layout, we create a family of products, so they are going to be related in how they're made, related in the materials they use. And what we do is we group those families of products together and we put like our machines closer together. So when we talked about process layout and product layout, we talked about the different downsides to each one. One of the layouts, when we look at it, if you have one machine or process that's down, the whole thing is down. Another has too much work in process, too much inventory sitting and waiting. So the cellular layout is a hybrid of the product and the process layout, trying to give you the best of both worlds. And so what you see here on the right is a picture of a cellular layout. And so what we've done here is we've taken what would have been that kind of assembly line product layout, and then what you do is you curve it so that you can have less workers managing more space. We're grouping the different production lines near each other. So you may have a similar production line not far away so that the workers who are skilled in that particular area can monitor both processes, and we can then have machines that do similar things near each other. There are 3 more things or components of designing a just-in-time process. So let's look at those. And the 6th one is to prevent defects from occurring. We talk about preventing defects before they occur. One of those components is what's called a poka yoke. A poka yoke is where we prevent defects from occurring. So it's any type of mechanism. So we'll talk about mechanism to prevent defects before they occur. So, for example, when you go to the ATM machine and you put in your debit card to get money out of your checking account, when you are done, notice that you are given your card first before you're given the cash. Well, why do they do that? They do that because people forget their ATM cards, their debit cards. And so if they give you the card first before the cash, you'll remember to grab the card. If they give you the cash first, then we tend to grab our cash and run away. So the idea here is a poka yoke, a mechanism to prevent the defects before they occur. So we're preventing you from leaving your ATM or debit card in the machine. The other poka yoke that they have there is that if you do walk away without your debit card, what will happen is the machine will suck the debit card back in. This again is a poka yoke. It prevents the problem of the next person coming along and taking your debit card. And then we don't know where it went. And then we have all these security issues. So we can prevent the problem before it happens by having the machine suck the debit card back in. So these are little changes. Remember, Kaizen is about little, gradual, incremental changes, no big expenditures, no big consultant fees, no fancy technology, simple little tools to prevent defects before they happen. The mechanism is the poka yoke. That improvement process is Kaizen. So just in time is about preventing the defects before they happen. And in Blackboard, there's a link to a video, or on YouTube, I'll put a link to the video where you can then see another example of a poka yoke. This one related to a company that makes windows and the cases around them. All right, number 7, standardize the process. All right, my pen craps out. It usually means these notes are about to close themselves. Let's try getting rid of them and bringing them back. Okay. So number 7 is to standardize the process. If we can simplify our process and have a standard number of steps, then we are less likely to have problems in our production process and to have wasted time, wasted energy, wasted materials. So if you're involved in a Lean Six Sigma approach, which is really just using these just-in-time management tools, what you're likely doing is creating a process flow diagram, looking at all the steps in the process, looking at where's the value added, what needs to be done, what doesn't need to be done, and what can be the same steps when we do multiple different activities. Because we're good at memorizing steps and processes. And so if we can have as many of the steps of the processes to be similar, then we are more likely to abide by them, which means that we're less likely to forget things, have quality issues, that type of thing. So we want to standardize the process. And that's why we spend so much time this semester on building process flow diagrams. All right, and the last one we hear is really what you know just-in-time and lean manufacturing for, which is the little inventory. Now, having less inventory only works if we've really been able to do a lot of these other pieces, right? So when we talk about reducing the inventory has always been a safety net, a protection. So inventory covers up the problems within a company. If you have extra product, then we don't notice that you're having issues with delivery and working with your suppliers. If you have extra inventory, we don't notice that you're having to over-process your product and go back and make it 5 times, because you always have some when the customer looks for it. You always have excess raw material, so you're able to make what you need to make. So inventory really just covers up all the problems in a company. If you're really going to have lean manufacturing and reduce the cost of all that excess material and reduce that waste of throwing away product that's lost value, having it depreciate on you, you no longer have that protection. That inventory is no longer protecting you and covering up all the problems within your company. So when it comes to our just-in-time lean manufacturing process, we have to fix the problems rather than cover them up. So you can think about inventory as like the water level. And the rocks here in our picture are all the problems within the company. As long as there's lots of water there, you don't notice there's a bunch of rocks. But once we reduce the water level, you then realize there's a lot of problems. So the key here is not to keep the excess inventory, but it is to get rid of the rocks or the problems. So how do we do that? Well, we need to prevent defects before they occur. So we need to increase our quality, and we need to well manage that quality. We need to make sure we have a well-managed supply chain, good relationships, coordination, communication with the other companies, because again, those problems we can cover up. If we don't do good forecasting, if we don't understand what our customers want, okay, having lots of inventory covers up the fact that we made too many of one product and too little of another. If we just have tons of all of it, of both, and we wasted that time and effort on one product when we should have been putting money and time into the other product. So we can have less inventory, less safety stock, but we have to then improve the operations of our organization, which is really the fundamental here of the just-in-time lean manufacturing process.